Hello everyone, and welcome to today's webinar. For those who missed our last webinar on the NFPA 96 standards, I invite you to go view it on our YouTube page directly in order to better understand today's webinar on the ABC of commercial kitchen hood design system. On behalf of the entire Cadexair team, I would like to sincerely thank you for joining us today. So today's session will feature a simulation involving a building engineer seeking expertise to design a commercial kitchen hood system for one of his projects in order to ensure compliance with the code and that he has a product best suited for his needs. Please feel free during the presentation at any moment to put your question in the Q&A box. One of our engineers will either answer you directly or we will keep the questions for the end of the webinar. Please notice that to use this function through Zoom, you need to use the app directly in order to have the Q&A box and not through the browser. To begin the scenario for today, there is no one better suited to represent the expert in commercial kitchen hood system than our President CEO, Francis Brassard.
Hi, Mike. So I will quickly introduce myself. So I'm Francis Brassard. I'm an engineer. I'm doing kitchen exhaust hood design for more than 18 years, and I'm the owner of Cadexair. So, Mike, please introduce yourself.
So I'm Mike, and I'm the technical support and automation specialist at Cadexair. Today, I will be representing the engineer in building, seeking expertise to design one of my kitchens in one of my projects. So to begin the scenario, good morning, Mr. Brassard. I am looking to obtain two commercial hood systems for one of my buildings, and I have the layout with me given to me by the kitchen designer, as you can see here.
Perfect. Thank you, Mike. So perfect. We have a kitchen layout plan, and I will say this is the first step to do a good design. At the end, a hood, it's a box that will cover the kitchen equipment, and they have a multiple possibility of kitchen equipment that can be used in the market. So it's always something that the kitchen exhaust hood always need to be designed as per the specificity of your project. Also, I think it's really important to have a good kitchen layout plan, and also there's people like FCSI, so it's a specialist food consultant that will help you to design the kitchen for the customer, and also they have a dealer that have a lot of skills also, and often they have department to do this kind of drawing. Just to understand also, it's not about only the hoods, but also as an engineer, you will have to bring all the commodity to equipment like water, hot water, cold water, drain, gas, electricity. So often they will narrow it down a little bit more to be sure that everything is really clear for everybody on their plan. So it's something that could help a lot. So if you take this example right away, your example, how we will design the kitchen exhaust hood, it's pretty easy. Normally, when you have wall hood type hood, like the hood H1 on the top, we will use, like this one is better. Okay, so we will have a 6-inch overhang of the kitchen equipment of each side and 12-inch in the front. So that way we will draw the square box, and after that we will have the full dimension of the product. In the other case, you have a wall on the right, so we will put the hood. We don't need to have that much clearance on the right, but that's the way we will do the design of the box with these kind of layout.
Yeah, my kitchen designer informed me that there might be modification coming up on the layout. What is my deadline in order to notify you before putting everything into production?
Yeah, it's frequent. There's change inside of the kitchen exhaust, kitchen equipment, because in fact it's a little bit like a factory. So they maybe change what type of equipment, and sometimes a minor change could look not a big thing on the paper, but on our side could be a big thing. I think the last time to double check, and every time you put a drawing in production, always double check that the version used to do the hood drawing and the final actual drawing are matching to be sure the hood is right. And sometimes there's small thing that could look not a big thing, but if you take this example, we have a griddle in H1 and a 4-burner in H2, both have 24-inch. They have almost the same airflow, so if you switch them, it's look really simple, but on the other hand, the fire protection system could change or have modification. So the first time, it's before putting the hood in production, and also before doing the pre-pipe inside of the kitchen exhaust hood, we always require to have the most updated drawing to be sure to have the nozzle right at the right place when we will do a kitchen exhaust hood pre-pipe.
Perfect. I'll try to keep that in mind.
Okay, so when you design, I told a little bit on the previous slide, so it's the overhang of the kitchen equipment. A kitchen exhaust hood, a lot of people think it's like a shop vac that will bring up the smoke from the equipment and exhaust it. It's not how it's worked at all. A hood will retain the smoke inside of the hood, hold it, and after exhaust it. So as soon as the smoke get out of the hood, it will never coming back. So the most important thing is the overhang of the system. If we have problem on a job and you ask me, I prefer to have better overhang with less airflow than higher airflow without any overhang to help to solve the problem. So the requirement, and these ones are come from the listing of a product. So we have to have a 6-inch on the side of the equipment, 12-inch in the front, and 6-inch on the other side, so it's pretty obvious. As per our UL requirement, if we want to be doing a really good job, we also need to double check about combi oven. If you see in that case, when we have a half-height combi oven, we try to have 18-inch overhang, and when we have a full combi oven, we'll go to 24-inch overhang. The reason why is this, if the engineer know a little bit less about that kind of equipment than people in dealer and all this stuff, it will cook with vapor. So as soon as you open the door, you will create a vacuum that will move out the smoke from the oven or the vapor, and it will spread in the room. Normally, people are supposed to open the door, and a lot of models have double action, and you're supposed to like wait 5 seconds, 10 seconds to just let the smoke get out by the crack of the door. But I will say this is not what happened in real life. So if you want to have a good control of the smoke, you have better to get a good overhang over the cooking equipment. The other thing also is to have a 12-inch, if you have an island style hood, we always recommend to have 12-inch overhang all over the kitchen equipment. The reason why, it's because it's the same thing, it's the smoke have to go up inside of the hood. When you have a wall, if you look in this corner, we have a corner here, so it will be really easier to the smoke to stay there because it will be stuck between the wall, the hood, and the back wall. But when you are in island style, the smoke can go everywhere, and you're really more can be affected by what we call cross ventilation. So if you have airflow going left and right inside of the hood, that could give you some problem. Also, should maybe have said that on the other side. When an engineer or a consultant or a contractor send us a kitchen exhaust layout, a kitchen layout, just don't send us the equipment. Send us the full layout, because sometimes we will see equipment that will maybe require a hood that or the designer doesn't put a square for a hood, but it could be request or something. Or what happened on some project, we receive a layout like this, but I will say further left we have a dishwasher that requires kitchen exhaust hood. So if we don't see the information, I will say we normally try to ask you to give us the information, but today things go so fast, so give us the full kit. We will manage it, and sometimes we can help you to find some bug in the system and help to get a better project, because at the end, that's the overall.
Is the layout I provided what you expect as information?
For this one, this layout, we know, but maybe you have other option that can be double checked, or we don't know. Do you have a dishwasher on your project?
No.
So sometimes to have the the full layout of the kitchen will help us to do a better job.
Perfect.
So in that case, we put the overhang, so 18-inch in front of the combi oven for H2, so we have a hood 84 by 48 and 72 by 74. The other thing that we need to size, and I will say this is a more tricky part, is the height of the hood, because It's really easy to do the square, but the height, you really need to go on site and have some information about what is the height between your finish, your floor, and the full height you have in your ceiling. So do you have this information, Mike?
Yes, in my case, I have 8.5 feet between my finished floor and my ceiling.
Okay, perfect. So that's not a lot if we talk about 8.5 feet inside for the hood. So technically, if we are looking at the full design of a kitchen exhaust hood, where as per our UL listing, we need to be 42-inch higher than the cooking surface. Almost all cooking surface are at 36-inch from the ground. 36-inch from the ground to be easy to be operate. So the fryer, the griddle, and everything are almost all like that. So usually the front bottom lip of the hood will be at 78-inch. The standard in the construction of a hood, everything can be custom made, but I will say the standard will be 20, 24, and 30-inch. So sorry for the people working in metric. I will say I learned a little bit more in imperial measurement. So in your case, when you have only 8.5 feet of height, that's not a lot. So we need to use what we call a taper hood in your case. So if we get an example of a taper hood, so we have a front panel here at only 6-inch to be able. So we have 78-inch plus 6-inch. So it will result that you will have an 18-inch clearance between the top of your hood and your ceiling to be able to put your ductwork. So, and we will keep a 20-inch in the back to be able to keep the same filter cage as any hood, so it's a little bit easier for us that way. In your case, also when you don't have a lot of height, we can also use what we call a back duct collar. It can be in the back to help to resolve that problem because you save all the space for the ductwork on the top. And we also have done what we call reverse hood. So instead of the duct collar, it will be in the back, it's in the front of the hood. So when you don't have any height, we always have to find a way to make that happen. And also really important, if you go with that type of solution, what will finally happen is the hood or the filter inside of the hood will simply be lower and lower and lower. So if you have like big combi oven, in your case it's a half section, you will not have any problem with that. Or you have a kettle with a big lid, you need to double check to be sure there is no mechanical confusion between both of them.
Okay, so now that we've determined the dimension of the hood, how do we choose my fan and the airflow that I require for all of my cooking appliances?
Yeah. So I will say all kitchen manufacturers probably have their ways, but I think it's almost all similar. We're working with chart that will use a CFM per type of equipment. If it's electric or gas, it will take less or more. At Cadexair, we choose to put 125 CFM per linear feet when there's empty space. We understand that we'll maybe exhaust a little bit more than others, but at the end of the day, we understand the energy efficiency is very important because kitchen exhaust hood system take a lot of energy when you bring back the air you exhaust. But something I learned, more you try to be on the exact value airflow, sometimes you will be a little bit short sometimes, and when you're short, you will have problem. And I will say nobody like to have problem. After that, you need maybe to change the motor, change the sheave, the pulley on the kitchen, on the fan. So there's more work and involvement to make it happen. So when you try to go at the minimum value, sometimes you could have problem. And I will say nobody like to have problem. So we prefer to be in a zone where we'll be safe and we are sure the system will work. The other point is important to understand is cooking appliances are not used the same way by everybody. So we have a chain that they use a grill only to mark some pita or thing like that. So they only just mark with the grill. I don't have to put the same airflow as a guy who's doing, I will say, chicken on the grill and every day with sauce that create a lot of smoke. But when you're doing a lot of project, you don't know what the customer will do, and often the customer are not sure what he will do. So we try to be in a zone that the CFM will be right at every time and to not have a problem down the road. So after that, we know the space, the free space in the hood, we know the cooking appliance, so we're able to get the total CFM per hood. So this is the old chart that we use at Cadexair, so this has been around for many years. So we have gas and electrical equipment as per which one will be used, give us a CFM per linear foot. So the reason why gas is a little bit more, ask a little bit more, if you take an example, you've got a griddle or a fryer, at the end you have a heat exchanger, so it's like a flamethrower in a tube, and after that all the combustion gas have to be exhaust too. So that's why we have a little bit more exhaust airflow from gas equipment than electrical equipment. The other point, if you look at the kettle, we have a value 200 CFM now we per feet. So now we change a little bit about that because it's like the pizza strategy. So if you have like a 20-inch kettle between a 24-inch kettle and a 30-inch kettle, you have a lot more area around it. So now we put more the capacity of the liquid capacity of a kettle, because when you go 1 feet bigger, you have a lot more vapor and smoke. And I will say, like a kettle, it's an equipment that can be sometimes a little bit tricky if they operate a lot with the lid open, full power, that create a lot of vapor. But if they operate with a closed lid, that's not a lot. So we have to be able to make it fit to everyone, because we are not sure how they will operate the equipment on site. So after that, in fact, how it's really happened at Cadexair, it's when we are creating the system for each hood, we have drop-down lists with equipment and attribute, and even often the real model of the equipment. So we choose the equipment with the attribute, and this is linked to a CFM, and we will have the exact value of the airflow. So in that case, I will not do the math right here, but we know the length of the hood, and we know the length of every cooking appliance, so we will take all the gap. So in that case, it's 22-inch of gap, so we will add 229 CFM. Sometimes we are stuck, we can reduce this value just to fit with any other consideration. Or if we take an example, in that case, we have a hood in a corner. So when you're in a corner or between three walls, you can reduce the airflow, because you will have a less problem to control the smoke, because the corner will help you a lot to control your exhaust airflow.
In this case, would it be preferable that I provide you the specs of every appliance that I'm intending to put under the hood?
I will say we like to get it, but we will not check all of them. I will give you an example. The griddle is pretty straightforward, okay? So it's always the same size. Often people really double check the BTU of the cooking appliance. Mm-hmm. In my case, I don't use that much the BTU, and the reason is why it's, if you use a fryer, you will work, your oil will be something between 375 Fahrenheit and 400 Fahrenheit. I'm not a fryer specialist, but this is what it told me. The difference when you have more BTU in your fryer, it's the time it will take to reach your set point. So yes, you will have a little bit more combustion from the, if it's gas, yeah. But at the end, the main source of heat, it's the oil inside of the fryer. So we have a bigger difference if we have an 18-inch fryer, because the oil pan is bigger. So we have a little bit more airflow per feet than a smaller fryer, because you have a bigger oil pan. So it's the same thing with a grill. You can have more BTU on your grill, but at the end of the day, And I will say I'm really not a guy that work a lot in the kitchen. I want to be honest about that. But if I do steak and you put your grill at maximum, your steak will probably be burned. So you have to lower. So at the end of the day, you need to get a temperature on the top of your equipment, and the BTU, it's how fast you will reach this, because almost all equipment will try to get to a set point, so they will just get there faster or slower. So we will work as per what temperature will be final on the equipment. So that's how we
Very clear.
We manage it. And some equipment like combi oven, we like to get the spec sheet, because if you look at this one, we know, because we spoke, that it's a half combi oven, but if we don't know if it's a full, it's a half, and even have smaller one, so it's help us to understand exactly. And sometimes there's weird kitchen equipment, the drawing block is not clear, we only have a square on the hood, we know our stuff, but we need to get a little bit of help to understand exactly what we have.
Perfect. Thank you, Francis. That was very clear.
About the, so we calculate the airflow for the kitchen exhaust hood, 1,520 CFM for H1, 1,180 CFM for H2. So now we have to put our dot color on the kitchen exhaust hood. So normally at Cadexair, your dot color is 10 inch deep. We will show you, I will explain to you a little bit later why. And after that, we try to have something around 1,500 feet per minute inside of our ductwork. So this is how we control the width of the ductwork. So we put one duct color per 11 feet of hood, and if you're over that, we will put two duct colors. The main reason is if you have, I will say, 14 feet long hood with one duct color in the center, what will happen is you will have more airflow through the middle of the hood and almost nothing at the end. So by putting two duct color, we have a better representation of the airflow all around the duct plenum. It's give us a good end to do a better job, and to be sure if you have, I will say, a grill at the end of the hood, it will help you a lot to have second duct color to have a more equal spread of the airflow all around the plenum bank. And also, this is the last one, and we'll explain to you the duct color position need to be behind the filter. Often we get job and we see a general drawing and they put a duct color right in the middle of the hood. If you have a type 2 hood, that could be okay, but as soon as you have a type 1 hood with the filter, it's logical, you need to have your ductwork behind the filter. So what can we do? So we put an example here of a kitchen exhaust hood layout. So we have two hoods side by side. So I put some red arrow on left and right to show you where we can move the duct color. So the one on the right need to stay in this area, and the one on the left, because it's two side by side hood. So this is, we can move inside of this area to be able, because we need to stay behind the filter.
So when I install my dock, I can place it where I want.
No, exactly. You cannot put your ductwork exactly where you want. If you have some different problematic on field, we need to discuss how to find the solution. So I can try. I will show you two others a little bit later. And also, what is the front and back movement that we can do? So if we take a zoom here, the duct color need to be behind the filter. So technically, the back, we have a 3-inch spacer here, so we have 3 inch between the back of the hood and the duct color. That's the amount of space that we can move. And if we look, we have probably 2 inch, if memory is good, between the front lip and the front lip of the top support of the filter bank and the duct color. So we don't have that much space to move up and down. If we want to have a little bit more, maybe a 1 inch, 2 inch, 3 inch, we can do a custom exhaust filter chamber that will be a little bit further, bring the filter a little bit further in the side of the hood, so we can try to find solution. So like we told a little bit earlier, we can put a ductwork in the back or in the front of the hood. Yes.
Okay, but in my project, I have multiple hoods, Francis. How do I balance both of them?
That's a good question, and in that case, if we look, probably we have a small bubble written for. I know it's not the full design. In that case, at Cadexair, when you're the hood, multiple hood on the fan, we always at minimum put what we call a sliding damper. So if we give an example, it's maybe the hood on the left, it's 1000 CFM, the hood on the right, it's 3000 CFM, so we have a 4000 CFM fan. So we start the system, and for any reason, we have 500 CFM on the left and 3500 CFM on the hood on the right. So we have 4000, so I cannot do anything with the fan. How can I manage it? We will use the sliding damper in that case because the hood on the right have more airflow than the hood on the left. So we will use this part and we will slide it inside of the dog collar to simply blank a part of the dog collar. And this is a listed product just to be sure. So it will create restriction inside of the dog collar, so it will help the air to go inside the other hood. So that's a way to make it happen. And because I got this design right now, this is something I think we are doing, I love doing. It's what we call an open plenum. So the front of the hood, the middle panel is almost all removed. And the reason why, we made some project, and the real reason we were in a casino, and that was an old project. They move equipment around, and now they had a big kettle right somewhere at this spot. And where the light is. So what happened, they opened the lid, there's a lot of vapor coming in, so the smoke start turning and was just stuck in the left panel of the hood. And after that, the left side of the left side of the hood is full and it's leaked by the front. So I say, yeah, that's not really fun because we have a lot of filter right on the left. So we just open a hole inside of the hood, and it will allow the smoke to go on the other side to solve the problem. So it's helped to contain. Bigger is the hood, bigger is the containment. So nobody cares if your smoke is taken by 3 filters on the left, 2 filters on the right. They just don't want to have the smoke in the face and the smoke in the place. 2 other solutions for dog collar. We can also do what we call a V-shaped hood, so it can be bigger than that, but we often use that kind of configuration when you have like a grill in island style or a walk in island style. We often work with that when we're doing a food court. So if you have a grill that needs a lot of air and your island, we will use that type of configuration. And sometimes because you're stuck and we need to have really the dog collar in the middle, there is nothing else we can do. We can do that kind of configuration with a double filter bank to be able to put the ductwork at this place. And that's an example of one, I will say, most complicated job I've done. It was in a basement in Mont-Tremblant, just at the bottom of the ski slope. So that's the hood, and we create like a ductwork linked to the hood. And was a 16 feet long hood, so that's why the ductwork is so big. So I will say, and it's it was normally a double V-bank because it was a big cooking island station in the middle. But at the end of the day, we will fought hard to find a solution for the customer. So this one, and I think we have to go all around a column in the middle of the hood. That was not the easiest job in the world. So what we need to understand, it's if you have a Type 1 hood, your filter always need to be behind the hood. Behind the filter, sorry. The dog collar need to be behind the filter.
And for more information on what are types of hoods, please feel free to see our previous webinar where we mention all different type of hoods as well. So to proceed, okay, but to coordinate the collar location, Francis, I don't have a lot of space. Can you let me weld it on location?
Sadly, no. It's really as part of the UL listing of the product. So the dog collar, to put the UL label on the hood, we need to have a dog collar. It's part of what we call the follow-up procedure. So UL come to our facility 4 times a year, not unannounced. So if they're seeing a hood without a dog collar with a label, they can give you maybe not a fine, but they can give you a new process to follow, and if we don't follow the process, they can remove our listing. So we want to do it right. This is what it is about at Cadexair. And if we talk about it, also you also need to have it's not mandatory to get a hanger in the corner of the hood if you see the bottom picture, but you are not allowed to use a rod and go through the top of the hood and put nuts because you're making a hole inside of the integrity of the hood, and it's not allowed. So you're supposed to use hanger or maybe any other way, but you're not allowed to use a rod to go through the kitchen exhaust hood.
You would void the listing basically of the product itself.
Yeah, technically yes.
Okay.
If you have, after that, we have other question for you, Mike. When you're
Yes.
designing a hood, you need to understand that we have to have some clearance about combustible and semi-combustible material. Can you talk to me a little bit about the structure of your building all around the hood?
Sure. Luckily, I went on site yesterday, so I have the information. If I look at my layout that my designer gave me, behind the hood 1 that we've labeled H1, I know that the wall is firstly made of drywall on a metal structure.
Perfect.
Behind the hood 2 that we've named H2, I know it's a ceramic tile wall. And the other wall where the entrance is, where the airflow would be coming from, I know that it's mainly wood.
Okay, perfect. So if we look at this, we have semi-combustible structure on the back of H1. So we only need a 3-inch air gap between the hood. Same thing on the back of H2 because you talk about ceramic, but it's almost sure your ceramic will be glue on the G-Proc. So. Yeah. Technically, it's really the stud of the building that will help you to say if you're combustible, non-combustible. So if you have wooden stud, even if you have G-Proc and ceramic, you still have your 18-inch clearance need to be respect for your wood structure. So on the right, this is what you tell me. So you have wood on the right. So yeah. What we will do, it will have a 3-inch spacer, and we have a listed insulation that can be put inside this panel, and we have 0 clearance. So if you have, for us, what's important to know is where is your combustible material, because at the end of the day, if you are semi-combustible, we will keep a 3-inch gap, so we have to fit it or not with insulation. Also in the back of the hood, sometimes we can have, I will say, block structure or non-combustible structure, so we can have 0 clearance. I always prefer to keep the 3-inch clearance, and the main reason why it's because this 3-inch clearance will give a little bit more space for the installer to be able to weld this dog collar, we install it, because if you don't, if you're directly the back panel of the hood, if you remember correctly, we had 3-inch of gap between the back panel and the dog collar, so it don't give you a lot of space to make that kind of installation. So I prefer to keep the 3-inch spacer, and sometimes we're not sure what happened, and you always are at least good to put 3-inch air spacers for any reason. If it's combustible, we can only put back some or wool inside of the hood and be able to do it. Something also it's important. Do you know what is the joist you have in your ceiling?
Yeah, they're wooden joists. I didn't think that was important to mention. Is it something that you need to know?
Yeah, it's really important because also it's not only the side of the hood, it's also the top of the hood. If you remember correctly, when we talked a bit earlier and do our taper hood, you are at exactly 18 inch of clearance between the top of the hood and your joist or your finish or the maximum space you have in your ceiling. So we're correct about that. But now you will have your ductwork. So your ductwork, you will need to use a fire wrap or any listed ductwork for 0 clearance, because it's sure your duct will be near at least of 18 inch of these joists. So you need to have some protection with like FireMaster or an equivalent product to be as per the code. Also, I'll send you if people want to double check, we put the most common one that are listed in NFPA 96 to see what is combustible, limited combustible, and non-combustible material for the assembly structure. So in fact, if we have a quick resume, 3-inch clearance for semi-combustible material, 3-inch, and if you have combustible material, we will put a 3-inch spacer with listed insulation and that to have 0 clearance from all combustible material.
Perfect. So now we've determined the dimension, the installation, the flow rate, the colors, the spacer. I have everything I need to proceed?
Sadly, no. It's a little bit complicated. It's like a car. There's a lot of options that we need to go through to be sure that we provide the best solution for your customer and his expectation. So first thing first, it's about what type of light you can have in a hood. And I will say mainly you have the built-in LED light or the incandescent, or I call it the fishbowl. I will say the only reason that we will use the fishbowl on the right, it's only on economical perspective. So what could happen, it's a glass also if we look at the light on the right. So if you receive any hit on it, it can break down. You need often also to unscrew and change the light inside of it. And we do a lot of cleaning, and we have always picture in the hood after and before. You can be surprised how many hood they have burned light inside of it. So when you go with the LED fixture, you have a better light quality, we have extended lifespan, you don't have to touch it for many years. And also when you buy a LED light, what is more important is to have the heat sink outside of the hood. There is some equivalent or people that will sell LED light inside of the economic fixture, but the problem with that is the worst enemy of LED, it's heat. So you're stuck inside of the glass bowl, you have a lot of heat, so one day the light will finish. And that's a true story. I built myself a commercial kitchen exhaust hood for my barbecue outdoor, and I use the cheap one with the screw-in bell, and it doesn't stay on for more than 1 year because of the heat and everything. So I think it's better to go, if you have the money, you go for the left, or you use the economic one and you use like a fluo compact or standard incandescent light. It will do a better job than the screw-in LED.
And the fact that the heatsink is on the outside, it extends even more the lifespan of the LED.
Yeah, for sure, and that's why they are created that way also, because that's a hood, it's hot. So you have a major heatsink. There's different model on the market, the one we use, but it's the best feature to have about the LED light is to have your heatsink outside of the hood to help to dissipate the heat over the hood instead to be stuck in the fishbowl.
Perfect.
The other point after that, you can go with the standard filter or high efficiency filter. The filter on the left, this is the one that we saw on every job, every time, every day. And after that, all kitchen exhaust hood manufacturer will normally develop their own filter. So it's a high efficiency filter. Normally they will have a better fat particle, or they will have a better retention or captation of grease particle inside of the filter. What I like with the GeoVary, it's maybe not the best one to get the smallest particle, but it's a filter that is extremely difficult to clog. They have a lot of space inside the filter, and we have a good result on the captation with this product. And also we can optimize the airflow over each cooking appliance with a baffle inside of it. And the great feature about that, it's by optimizing the height or adjusting the filter, we can, if we have an equipment that requests less airflow, we can choke the filter and we still have a high degree seeing or removing the fat particle from the airflow, because in fact it's a question of speed and change of direction. I cannot talk too much about it because we have a lot of stuff to say, but if you want to go with that kind of filter, you will catch more grease at the source. So, and also because the way it's built, it's a little bit, it's a good function to reduce the risk of the fire to spread inside of the plenum, because all the filters are individual one by one. So you need to go down almost 16 inch, go up 12, 14 inch, and after get out. So the flame have to go a big curve instead to just traveling through 2 inch in the normal filter.
Talking about docks, I know I have a long run of docks in my project, so I'd want a filter that's more effective to avoid grease accumulation and having to clean it often. So in that case, I'd have to go with your GeoVary technology, right?
I think that's a good choice. When you have a long dock run, you prefer to keep the grease inside of the hood than to have to remove it downward the ductwork. Cleaning ductwork, it's not that easy. At Cadexair, we have over 10 teams doing hood cleaning almost every night. So you need to open access doors, spray the greaser, scrape it. It's not that easy. It's not a magical robot. So the more you remove grease from the ductwork, easier it's to clean, and you have maybe a little bit less problem with maintenance down the road.
Yeah, I'd want to avoid to have to do those cleanings as least often as possible. So
Yes.
the GeoVary is the way to go.
Yeah.
Perfect. Thank you, Francis.
Also, after that, you need to check, do you need a demand control hood system? So first thing first, it's always where is your project, Mike?
In a building, construction building.
And where?
In Montreal.
Montreal, well, okay. And that's why I asked him this question. It's if you have more in Montreal, if you have a system with more than 5,000 CFM, you will need to have demand control system. But it will be different everywhere in Canada. So it's very as per the local energy code. If you talk about New Brunswick, it's 4,000 CFM. Halifax, it's 5,000 CFM. And if we go in Vancouver, it's probably 6,000 CFM. And if you go more north in Yukon, it's like 3,000 CFM. So sometimes this is a requirement by the energy efficiency code. So just to be sure, but in our case, we are around 3,000 CFM. It's not mandatory to put one. After that, it's a question of value, long-term operation. We will pay a little bit more to pay a little bit less in everyday operation. And also there's some area that you could have also some subvention from the government or the gas company that can be given to you because you have a demand control system. So all this is work really quickly. It will have temperature sensors inside of the hood. It's really easy. More you have heat, more we exhaust. If you have less heat, we will exhaust less. It's really easy. And after that, we can also use the same temperature sensor as the auto start function. So the customer doesn't have to start the hood in the morning. As soon as they will detect heat over a set point, the hood will start. And if it's come down the set point, the hood will stop.
Yeah, I heard that it was a standard or an obligation to have an auto start sensor, or is it just based on my need or if I have a smart system?
No, since NFPA 96 2014, it's required to have auto start function. So if we have the demand control, or what we call in our detect system, it will be built in. If not, we will have a temperature sensor with a dry contact. So if we hit certain set point or something around 35 degrees Celsius, the hood will start automatically. If you put your system on in between, it will stay on. And if not, if you didn't touch the system, as soon as we go under the set point, the hood will stop. So that's now a requirement of NFPA 96. There's different way to do it. That's the one we use. But in fact, what is required is to link the cooking appliance use with the ventilation. So as soon as you're cooking, they want ventilation. When you have a demand control system, something is important to have. It's to have a double detection. If you only have temperature sensors, can be a little bit slow to react to the system. So to have a double detection system, optic sensor, in our case, we use what we call the detect sensor. So it's really a motion sensor that when you go under the hood will go a little bit faster. And also why we create this, we work a lot with optic sensor on big system, like an hospital with 200 feet of hood. So when they open the combi oven, the time that the exhaust fan on the roof with a 20 HP motor want to accelerate, it's too late, the smoke was already gone. So the purpose of the detect is to have an action faster than seeing the smoke, because sometimes when the smoke is there, it's already a little bit late. So this is what we like also about the system, is the detect cannot be misaligned as per an optical sensor, and also it cannot be if they are dirty because it's optical, and we live in a hood, so they're always full of grease. So it's more, it will not be dirty. You don't have to wash the lens. So you can put 1 inch of grease all around the detect sensor and it will still operate because it's like it's a wave, like a radar that they are used with that kind of system. Other thing after that, it's a new building. You're in an existing building, and you're.
It's a new construction, new building. Yeah.
This is sometimes a little bit less a problem, but often we're doing school or project like that, and I don't know. I will say in Quebec here this winter have been really difficult, -20 a lot. So we made project and we received phone call about it. So we're doing a school. We didn't put any damper in it, and for any reason, the building, if we exclude the new part or the modification have been done, is a negative pressure. So technically the building exhausts more air than bring in on everyday basis as per modification a long time. So right now what happened is we have a shaft of 10 by 20 or 10 by 15 going outside of the building, and as per NFPA 96 we cannot put any damper inside the fan, the ductwork. The only place that we could put a damper is as per a hood accessory. So we can use this damper to minimize the airflow return inside of the hood in case of negative pressure. I will say in that particular case, they were complaining the filter was full of ice and it was really cold inside of the kitchen when they shut down the hood. But at the end, it's not the problem, it's not the hood, it's the balance, the overall balance of the school, but this is what can be done. In your case, in your project, Mike, if you want to aim to a high efficiency system on the energy, we have also modulating damper that can be installed on the kitchen exhaust hood. So these damper, what will happen is you have two hood, hood H1, hood H2. So for any reason, they're working a lot on hood H1, there's nothing really happen on hood H2. By using this damper, we will open more the damper over hood H1 and have a less airflow on hood H2. And after that, we can send our air at the right place at the right time, so we can exhaust less air with that kind of system. So it's something that can be done. It's also help for balancing and everything. Same thing as the two-position damper. We can use it and not fully open or fully close, not fully open it to help balance. So that's something that can be used to improve your energy efficiency with the modulating damper. If we go to your next webinar, if you assist, we will go a little bit further how we will use that kind of in a centralized system and explain to you how to design a full centralized system with that kind of product. So if you're interested, it will be presented in the next webinar about how we can use modulating damper inside of our system. After that, another important part, as soon as you have type 1 hood, you will be required to have a fire protection system. So technically, when you have back-to-back, end-to-end hood or sharing an exhaust duct to the same fan, it's considered at the same risk, and they share the risk. So you need to have the fire protection system discharged. So how many fans do you have on your project?
Only one on this one.
Only one, and is that the good choice? If you have a long run of ductwork, you're better to put only one fan. So technically, the boat system, the boat hood, they need to have a fire protection system that will be released at the same time. We also often ask me that kind of question. Do you have a sprinkler in your building?
Yeah, we have water sprinklers.
Perfect.
Yeah.
So a kitchen exhaust hood type 1, it's considered covering space. So don't have to put any water sprinkler in that case because it's already protected with the fire protection system of the hood. So NFPA 96 will tell you that in that article 10.7.1 that you don't need to put any more water sprinkler near a hood. So how to choose your fire protection system? First of all, you need to have a fire protection system that have a certification UL 300. So that's pretty simple. I don't think there's a lot of people are building fire protection system in their basement. So normally, if you use a commercial kitchen exhaust hood fire protection, you will be you'll be good. So there's an option. You can have stainless steel cabinet. So this one on the left, it's like an Ansel R102, and on the right, it's like a KDW HDR. So, and also there's an option to put it directly on the hood. But mainly the main part why we choose one on the other, it's the aesthetical part. So I will say if you have an open kitchen, I will try to put more the one in the stainless steel box. If it's a closed kitchen, I will go a little bit more with the cylinder type. The main reason why also people are a bit afraid of that kind of system. So I went on a job and they are repaint all the kitchen, but you see all around the fire protection system is still yellow because the paint was really nervous to touching the system or everything. So that's more a kind of which one is more beautiful or more practical than the other. And I will say all kitchen applications have different pros and cons. I will say normally if we call about the KDW HDR, they are better on the detection line and on the coverage, but they have less point in the liquid, and we will try to show you a little bit how it's work. So technically when you design a fire protection system, all appliances have a number of points linked to them. So technically if you have a fryer, and I will say as per the manufacturer. So if we look at the Ansel system, we see the one in the box. We need 3 points to cover a normal fryer. If we go with a KD, it's 2 points. If you have a 4-burner at the like we see in at the bottom with a KD, it's 1 point, and with Ansel is 2 points. So it's always different as per manufacturer and their certification. So also we never have to forget, as soon as we have a type 1 hood, we need to have a sprinkler behind the filter, and also one that covers the dot color, and the number of points is always as per the length of the hood and the size of the dot color. If we look correctly at this one, so we try to make a schematic of everything. So in blue, it's the detection line. In pink, it's the suppression line with the agent. So if we're going through, you've got your detection line. You have a fire stat. It's a fire stat. You've got your fire link right over the cooking appliance. You have also one inside of the dot collar. And after that, we get out of the hood with the detection line where it's a wire that it's linked to the, I forget the fuse, it's not the fuse, it's the fusible link inside of the hood. So in that case, if we look at the kettle, we don't have any fusible link because we don't have to put any sprinkler over it. So we don't have to put a fusible link. So this one is in the dot collar, but it's also shared with the griddle. So it's the same one. For each manufacturer, that's the rules that they can go like few inch on the left and the right to cover equipment. And after that, we have another one over the fryer. So normally it's almost one fusible link per cooking equipment, but if you are over the dot collar, you can use the same one. After that, it's a little bit different for everybody, every job or we will simply add up all the points for all the equipment, and after that we have to spread it as per the cylinder. So in that case, it was easy. We only have one cylinder of 11 points. So we had 11 points on 11 points. So it's a maximum system. So if you change anything or for any reason you change your griddle for another 4-burner, the system will be too small. So we will need to add another tank on the left. Or if you have maybe a WHDR from KD system, you will need to put a bigger system, a bigger tank, and change the full tank. What we try also to do is we put a table and we will give what is the cooking appliance, what type of nozzle will be installed, number of point of the nozzle, and after that, what is the requirement of installation. Like I say, per manufacturer, each requirement is different for each cooking appliance. I will not say it's always almost the same, but they can have difference, or they will put the nozzle. So if we look back quickly at the griddle, a griddle, you need to have like a 45 degree on the perimeter that shoots toward the center of the equipment, and also the height as per the cooking surface need to be respect. In case of fire, the gas must be got to all the cooking appliance. You can have an electrical or mechanical gas valve to do it. So an electrical gas valve, the great point about an electrical gas valve is you can shut the cooking appliance for other reason. There isn't a fire in the hood. So I will say if you are in a shopping center and the main alarm and the evacuation need to be done, we can shut down all the cooking appliance. If you use a mechanical valve, it will only shut when the fire protection system of the system will be released. So it's a little bit more difficult to shut down your cooking appliance if it's not. Also, electricity must be cut to all cooking appliances protected by a fire suppression system, and the primary energy source is electricity. So if you are, in your case, Mike, you have all gas equipment, so this is not a big deal. But if you have more electrical equipment, so if you have a gas fryer with an electrical controller, you don't have to shut it down, the electrical controller. You only have to shut down the gas. But if you have electrical fryer, you need an electrical fryer. You need to shut down the full equipment, because the main part of or the main energy source is electricity. I know this is what is written down in the code, but we have received some call or some problem on job. They require to shut down the outlet near the hood. They require to shut down an electrical oven, even if it's not as per code. So always double check with your authority having jurisdiction. For our side, we're always able to comply to the sequence, but we need to understand that when you have electrical component, you need to have electrical device to shut it down, like magnetic contactor or shunt trip. The exhaust fan, when you get a fire, the exhaust fan stay on. The makeup air is turned off, and you don't forget, you always need to have a type K extinguisher when you have cooking appliance. Okay. And also you will need to position a manual pull station between 42 and 40 inch off the ground, also outside of the hazardous area, so it's on the path of egress need to be done.
Okay, Francis, well, all of this seems great, but that's a lot of elements to coordinate together. How can I ensure everything is respected as per code and that it's simple for me to manage as well?
Yeah, we have created different series of control panel, from a really basic at the CS series to relay with the CC25 series, and we can also use PLC and or more advanced if we use like a DTEC system, the CC200 series. If we are doing, I will say, bigger project far from Cadexair, we can also have an internet access that can be allow us to go inside of the software. And also have the BACnet, MSTP, BACnet EP communication protocol. So, and we have a lot of feature in this in this control panel.
Okay, if I want my system to be fully automated though, with least interaction possible from my employees, which one should I choose?
With the CC200 series, technically everything can stop automatically. Nobody have to push a button. The only thing you have to do is to do a reset if you have a power failure. So I will say that's one is have the minimum interaction with everybody inside of the building.
The simplest one to use.
Yeah.
Perfect.
And also we understand the coordination of this is not that easy. So we create schematic diagram. If you look, every bubble in this, it's a wire that need to be installed on site. So there's a lot of information. So we try to put each type of wire. I know it's really small, but we put each type of wire, how many conductor, what type of voltage, and also we put a category. So if it's A wire, it's by the alarm. C wire, it's controlled 24 volt or less. E, it's electricity 120 volt or plus, and we have BM probably somewhere. No, it's not there, but if you have building management, we also have a special wiring diagram. And also, I know this one is in French, we didn't translate it, but we also explain each wire, what is the purpose of the wire, because it's fun to know what you are doing.
It's the first time I see a plan that's as simple to read and understand. Very great plan.
Thank you, Mike.
Now that I think about it and looking at all the components involved, is my client actually able to afford all of this?
We understand that it's expensive and there's a lot of option in that. It's always to discuss what is the best. And also if you want to go a little bit cheaper type of product, we create what we call the standard hood. So it's prefabricated hood of 4, 6, 8, and 10 feet long. It's in stock. It's fast delivery. So in fact, all the panels are at Cadexair. So when you get the order, we put it together. We install the dock color exactly as per the requirement of the customer. So we can put it left, right in the back of the hood. We have option for low ceiling. So the side view with a 6-inch front lip hood in the example, it's a standard hood. And also we have all the option for air spacer, insulation, and insulation air spacer on all face of the hood.
Perfect. Thank you everyone for watching. Before proceeding to the question period, I'd just like to mention our future webinars that are coming up in shortly. So the first one that will be coming up will be on centralized system that you mainly find in food courts. And the second one is on air exhaust solution in mixed environment buildings, mixed use buildings as well. Sorry for the error. And now to complete, I'd like to tell every engineers who have projects or have projects on the way and want to do it right, please feel free to contact us for any question, pricing, quotations. We're here for that. It'll be our pleasure to assist you in that regard. So now, before concluding, we'll move on to the Q&A session to address any of the questions you would have. So please feel free to submit them in the box. Now is the time. So first question I have for you, Monsieur Brassard. Do we need fire protection in the commercial hood for a hot plate?
You mean the induction plate?
Induction plate, hot plate, yeah, they're
technically,
synonymous.
if it's under hood, yes, because you can put a pan and cook a steak in it. So technically, if it's under the hood, you need to do it. I know they often use that kind of equipment a little bit everywhere in the kitchen, but if you put it under the hood, I think, and you got a fire marshal, they will require you to get a fire protection nozzle over it.
Perfect. I think that answers that question. The second one. I encountered an issue in both senior residence and hospital where the electric valve shut off during a brief power interruption before the generator started. This required a manual reset to restore cooking operation. Are there any solutions to prevent this from happening?
That's a good question. It's happened to me and it's taken a long time to understand. Because what happened is every month the system was shut down, and if you have a big kitchen with electrical gas valve, it's really painful to light up all the pilot light. So in that particular case, what we have done, we put what we call a UPS, so it's like a battery backup. What we need to understand, when they got generator, they have to test it every, I will say, month or 2 months. So when they test it, they really put the power. So when they change the power from the main power line from the electrical company to the generator, our PLC will lose power for a few seconds. So if we lose power, we shut it down because we don't know if it will reopen in 2 or 5 hours. So we have to reset the system. So in that case, if we have a UPS, it will allow the system to operate probably something around 15 minutes with the light in the hoods and also the gas valve. So if you have that kind of operation, it will be a little bit more steady.
Perfect. Another question. I don't have space outdoors to install the exhaust unit. Is there a way to install the exhaust fan indoors instead?
Yes, it's for sure. Sadly, it was in our training, but we have too much material, so we had to cut it back. Yes, if we just maybe, I have it right here. So we have model of fan, so we have inline fan can be put inside. So as soon as the fan is listed as per UL 762, or have a UL75 power ventilation tested for cooking operation, the fan will be allowed. So the inline fan exists to be put inside of the building.
Okay, perfect. I think that answers the question. Can the filter section be moved to the front of the hood to create more space for the duct collar?
Yes and no. Like I told you a little bit earlier, if we bring the filter a little bit in the front, so what happens, it's all the filter will go, so it's create a gap here. So often the cooking appliance will be right under. So what could happen is the smoke and the grease, so it can create condensation or a little bit grease accumulation. We can put a 45-degree angle in between. So yes, we can move a bit, but it's always need to double check. Or if we have to move too much, what we show, we can do a V-bank section that can be installed. It can be installed in the middle of the hood.
Okay, thank you. We have two more questions. Do we need to shut off the gas to each equipment individually, or can we have a single gas valve for the entire kitchen?
Normally, there's two things about that. Each equipment normally have a ball valve, manually ball valve to be shut it down. It's more a question about for a gas plumber, but in our case, it's not written down. So they request us to shut down the gas when the fire protection system is tripped. So technically, one gas is normally what we have on site, but we are doing some project. There's a lot of renovation. We have two gas valves. So at the end, what is important is there's no more gas when the fire protection system is released. So this is what needs to be done.
Perfect. Last question. How can a balancing contractor properly adjust the airflow, considering it does not appear possible to drill into the hood dock? The only apparent method would be to take a reading at the hood collar, which requires removing the filter. Is there any other way to do this?
No, it's not a good idea to remove the filter. First thing first, when you remove your filter inside of your hood to take measurement, you will change a lot the static pressure because you create a big hole in your system, so the static pressure will be lower than in real life, so your airflow will be faster. So I'm not a specialist in balancing. If you have a GeoVary, because the way the stuff is done, you can use a wheel to take the speed inside of the filter. Or I know when you've got a baffle filter, they use what they call a Velt grid. So it can take like 5 readings at the same time inside of the filter, and they can give the an approximated phase value of the filter. And I think they have conversion factor that give you the real airflow. So I think the Velt grid give a good job to make that happen.
Perfect. I think we're done for the Q&A. I don't have any more. So I would like to thank everyone for being present today and having participating on behalf of the entire Cadexair team. And to conclude, we also hope to see you in the upcoming webinar. As we usually say, we always keep the best for last. So before concluding everything, final words from our President, CEO, Francis Brassard.
That's what I say when I meet engineer and give that kind of formation. It's difficult to know everything about everything if you are designing building, cooling tower, chiller, kitchen exhaust hood. I will not say it's that complicated, but it's a lot of small stuff that need to be learned. So I think the good thing is to know which person know the right stuff and can support you with the question and ask you also the good question. So it's difficult to be the best at everything. I think it's easier to know who is the right person. So if you have any project, any question or anything about how to do a job or to do design for your project, feel free to call us or send us an email or call me directly. I'm sure a lot of people already have all my information. So give us a call and we will do all your best to help you to achieve a good project. At the end, it's the owner of the building and the customer that need to be happy. And this is what we try to do for the last 40 years. So thank you for your time and have a great week.